This is EC 4760. The class is slightly oversubscribed right now. I suspect that by the end of the week, it'll be down into the not full level, because experience shows that students sign up for about one extra course. So that's something like 20% oversubscription. But we will see. I'm not going to write very much on the board today, but everything you need to know about the course is on the website. I loathe Blackboard, and so and also I started doing websites for my courses before Blackboard existed, back in the days when VI was the HTML editor of choice. And so this is a URL for the course, or you can just Google ECE 4760. It should be the first hit. My net ID is BRL4. I'm in 214 Phillips. Stop by anytime you want to talk. You can also Google me at Bruce Land. It should be the first hit. And don't hesitate to stop by. I should note that Video Note is recording these lectures, and you can go to videonote.com and then punch the Cornell Students button up in the upper right corner. It'll ask for your net ID. You can log on and see the lectures, usually within 24 hours of the time they're given. At any time, if you have a question, stop me. I would much rather, all during the semester, I would much rather stand up here and answer questions about the labs than drone on about code. That means you need to read the code before you come to lecture. And also, unlike some people, I encourage you to bring your laptop, flip it open, and follow along on the code with me, because all of the examples that I give you for code are going to be online on the website. And you can either copy them by hand, or you could look at them online. We have 5 TAs who are somewhere in the back. In the back, or stand up, folks. So, from left to right, Victor is wandering around. Victor, Manu, Taylor, Shiva, and Tamid. And the sections that they are taking are up on the website. I guess we should go to that. Any questions about these? Have you already tried Google to see if you can get there? All right. Wow. That mechanism needs work. So I realized I'm not used to lecturing in this room, but I realized I better have a laser pointer because my arms aren't long enough. And even with but I have a meter stick here. Oh, I can get there with the, okay, that's good. I prefer physical stuff. And you can't see my handshake as much. Everything's on the web page. Assignments, particularly homework, which is due at the first 5 minutes of each lab, and lab assignments, staff and schedule, and then links. That's kind of generic, but it has a lot of the background material for the course. But let's go look at staff and schedule first before we look at assignments. So this is the current lab schedule. I would much prefer to have a Wednesday afternoon lab, but experience shows that other courses are scheduled then, and I haven't been able to make a lab work. So Tuesday, 4:30, everything's in military time because it's less confusing. So 16:30 to 19:30, 4:30 to 7:30 in the evening. Again on Wednesday, Thursday afternoon, Thursday early evening are both labs, and Friday there's the assigned TAs. The assignment due schedule is here. And daunting it is. Next Tuesday, the first homework will be due for the first group. Your homework will be due in your lab section, so next Tuesday evening, the first homework is due. That means you need to start it now, because the only way you can ask questions is on Monday morning in lecture. Second week, you're going to demo lab 1. It has to be completely working by the end of the second lab section. Anything that isn't working, you lose points. There's no makeup, there's no extensions. First week of lab 2, homework 2 is due, and the lab 1 report. Second lab, demo. Lab 1, lab 3, week 1, homework 3, lab 2. The only exception to this schedule is that on week 2 of lab 3, homework 5 is due before homework 4. Because homework 5 refers to lab 5, which is the design project, and we want about 2 weeks to evaluate your idea for a final project and get you feedback before you actually have to start it. So homework 5 is not primarily a grading opportunity. It is an evaluation opportunity for us to say the project is crazy hard, you're nuts, or awfully easy, or perhaps suggest how you could make it more interesting or more flexible or whatever. It is not too early. 8 minutes into the course, it is not too early to start thinking about your final project. How many people have an idea for a final project? Alex, of course. This group over here, are you all partners in the lab too? Oh, so what do you guys want to do? What do you want to do? Oh my God. Radar? Sure, why not? It turns out that this is feasible, possibly feasible, for the first time this year because we're changing architectures. There's no longer going to be an 8-bit Atmel course. It'll be a 32-bit PIC course, and the 32-bit PIC architecture has a CTMU, a charge time measurement unit that allows nanosecond resolution for short times. So you could expect, anybody know how long 1 nanosecond is in feet? Light feet? It's 30 light centimeters, right? So that's about a foot. So you get something like foot accuracy off of this if you were careful. Alex, what do you want to build? So we're talking, so let me get it straight. We're talking spinning knife blades, right? Great. Okay. The rule for 1 year, if you go back and look at the videos on YouTube for the course, there's a YouTube channel, ECE 4760, also what you ought to look at. I think 4 years ago, people did a grapefruit slicer, which had a turntable, a servo motor from a CD-ROM drive, and a big knife. And before I would let them do this, they had to get the safety interlocks correct so that, and we're not talking software interlocks here, that's not good enough. When you take the cover off that, it's got to cut the power to the CPU. That's good enough. So physical interlocks before you make the spinning blades. The consulting schedule is here. You will find that TAs are going to consult during lab periods. There will be a TA in the lab section. There will be a separate teaching staff who will be consulting and helping with the lab. I will be in 3 of the afternoons. You'll notice there's no section in Wednesday afternoon. I'll be there anyway for people who want to come in and work a little more. I'll probably also open it up on Monday and or Tuesday morning, although not next week, for more lab time. The dates for, now to go back to the assignments, homework is due at the time mentioned here. The lab assignments are the weeks mentioned here. I'm not going to say this again. It's on the web page. Don't ask me. Look it up. Demo? Yeah, just look it up. The design project will be demoed, is due the last week, the last regular scheduled lab section that you have. So Tuesday we'll demo on Tuesday, Friday we'll demo on Friday. At that time you have to have a working demo and a rough draft of the final report, which is a web page. The final report is a web page. You have to turn in the web page, the final version of the web page, on the date specified. I can't tell you when it's going to be because it's a date specified by the university. It's consistent with the rest of the final exam schedule and the time that this class meets, but it's not published until about 4 weeks before the end of the semester. So we'll know when that is, but it will be something like, it'll be between 0 days and 5 days after the last class. There will be an optional extension, an optional no penalty extension into study days for demoing the project. So it'll probably be more like December 6th or 7th. Any questions? Why pick 32 rather than Atmel's? Well, Atmel actually has 2 32-bit lines. They have the AVR 32, and they have a couple of ARM variants. And I think that the PIC 32 is easier to teach. That's why we chose it, we being Tamid and I. And I think that the register structure and the interdependency between program pieces is easier to understand. Now, this is somewhat subjective, right? It happens to fit into my brain better than ARM does. But we'll see how you like it. That's a caveat for this year. As of last year, I had been using AVR for 17 years. I knew a lot about AVR. This year, I've been using PIC 32 for 11 months. So, I know how to make it operate, but I don't know the failure modes. And experience shows that students think up an amazing number of failure modes. So, not trying to be mean here, it's really easy to misset a bit and in a register someplace. And with the AVR, I could say, oh, well, it's doing this and it's not doing that. Probably you didn't set the timer right. I can't do that with this architecture yet. So, the TAs, me, and you are all going to learn this together. Depending on your personality, that can be daunting or exciting. But think carefully about this. It's a new architecture. I threw away every bit of hardware and replaced it all with new hardware. Threw away every bit of software and rewrote it all. Maybe even correctly. Any questions on that? This is a standard MIPS M4K core. It has the usual set of timers, A to D converter, SPI channels, UART channels, like any microcontroller does. It also has a feature that is not on AVR at all, and that is a direct memory access channel, except for direct memory access channels. In fact, the memory controller has at least 7 bus masters. There's the instruction master for the CPU. There's the data master for the CPU. There's the data master for the USB on the go. Ooh, something else new. And then four bus masters for each DMA channel. These 7 bus masters can target 4 different targets. They can target flash, where the instructions are stored. They can target RAM, where data is. They can target USB, which has its own memory target, or the peripheral bus, where almost everything else is. So you can issue 4 bus requests on every cycle and have them fulfilled. This is very cool, very powerful, and slightly confusing. So concurrency, remember folks, 3140, prerequisite for this course, covers concurrency, interrupt service routines, I/O ports in general, 3140 for the Texas Instruments device, but they're all about the same. And I expect you to know that already. So the details of concurrency due to DMA accesses, you should have some idea how to handle, but we're going to talk a lot more about that. There is no yes. Pardon me? How many people in lab groups? I don't want any more than 3. 2 is probably better in terms of hands-on. If you have a compelling reason to go to a group of 3, I will do that. For final project, if you pick some gigantic, horrible thing, like radar, and want to have a group of 4 or so, I can do that. We've had trouble in the past making sure that everybody works the same amount in a group of 4 or 5. And we do reserve the right to differentially grade members of a group if one person is slacking. There is no text, but there's plenty of documentation, folks. There's a reading list starting here, all semester, you're going to refer to this over and over again. There's a user's manual for the oscilloscope. Fantastic. For the signal generator, the PIC32 reference manual you're going to use all the time, because this describes the programmer's model, the programming model for the CPU. It describes the registers and how they interact with the hardware. So this is going to describe how you control the peripherals. It is 1,130 pages long. You won't read all of it probably, but you'll read a good section of it, because there is no other way to figure out what stuff does. I've read probably a third of it so far in the last year. PIC32 peripheral libraries for MPLAB C32 compiler, which is what you're going to be using, tells you how to bind the description, the hardware description found in the reference manual, to C. It tells you how to manipulate the registers using C macros mostly, and a few functions. It's mostly just handy ways of laying out very arbitrary bit fields so that they're easier to remember. The PIC32 data sheet has the gory details of how the pinout, and this chip comes in several pinouts. We're going to use the 28-pin PDIP. The nice thing about using PDIP is that when you blow out the I/O ports, you could replace the CPU. Not that you will, but you probably will. And that's okay. This is a hardware course. You can't learn to build stuff unless you learn to break stuff and fix it. The current limit on the I/O pins for this CPU is what? How many people have read the? You will read the, by the time you get finished with the homework, you'll know that number. You'll also know the Thevenin equivalent resistance of the I/O ports, because that is going to matter. We are not going to use them only as logic levels. We are going to be using them as analog voltages. And therefore you have to know their impedance characteristics. Or are you going to blow up a port by hooking an LED to it? That's really important. Can you drive a 4-ohm speaker off of an I/O port? Think so? Yes or no? Who wants to hazard a guess? Well, exactly right. Don't do that. It will just toast the I/O port. And you might want to read the MPLAB IDE user's guide, because that tells you how to use the software. But nobody ever reads a software manual, so I don't expect that. Specifically for Lab 1, I want you to read reference manual sections 12, 14, and 15. Pick peripheral libraries for MPLAB C32, 10, 11, and 12, which correspond to these sections. Why didn't they label them the same? I don't know. And you might want to read Getting Started with PIC32. That's kind of a chatty introduction to the architecture. And required reading is the class overview and policy. And in fact, we're going to talk about that right now. So I'm just hopefully clicking that link, because this is the contract you are signing by taking this course. This is what you agree to do. There's a little section on reading here, which I've just about talked about. This is a design course. We're not going to tell you how to build this stuff. We're going to help you figure out how to build it, but we're not going to tell you how to build it. There are lots of ways of implementing most of these projects that you're going to be doing. There is no single right way. There's lots of wrong ways. But there's no single right way. And so you may find some very clever ways of doing it, and that's okay, that we didn't think of. So we're going to expect you to show a fair amount of creativity and flexibility and some motivation to come in and work on these things. Some strategies for what we expect. It's a culminating design experience course. That means we can ask you anything from any course. In particular, I like differential equations. And so a lot of the projects that I think of are differential equation based, like Lab 3 will be a video game. It's a video game I made up, so you'll never find code for it anywhere. It's called Particle Beam. And what you do is have to deflect billiard balls into pockets on the fly. So you have to do billiard ball dynamics. So it's vector calculus, really, to make it go. There's 4 projects plus a final project, four specified projects plus a final project. 50% of the grade of the course will be in the laboratory assignments, of the 4 lab assignments. Of that, 25% will be how ready are you to go when you get to lab? Have you done the reading? Do you have a code draft ready to go? Or are you still flipping through the book trying to say, which way is up on this web page? All right. 25%. 25% will be, did it work? Did you meet all of the design points in the assignment? The last 50% will be the write-up. Write-ups are important. Take it seriously. Particularly, you come in, you work hard, nothing happens, you can't figure out what's going on, nothing works. You make a good write-up on why it didn't work, you can still get 75%. If you worked hard and did a good write-up. So this is a chance to redeem yourself if the whole thing fell apart. But experience shows, starting early, thinking about the code, think about the structure before you start banging on the keyboard. Think about the goal of the project, which is to some extent getting inside my brain, will make a successful project and get you most of the points. You have to attend your weekly scheduled lab period even if you've finished the lab. Let's say you're ace programmer, you come in, you whip out lab 1 in one lab period, you demo out during the first lab period, you must show up for the second lab period or you will lose 25% of the points for the core, for that lab. You can always start on the second lab, you can start on the final project. There's always something to do in lab. You have to stay for at least an hour and a half in the lab, even if you've finished it. No late assignments, except of course for sickness or family emergency, the usual. Lab work is done in groups of 2 or 3. Collaboration is required within the group and forbidden between groups. We'll talk more about that. 50% for the final project. Since everybody does a different project, it's really hard to grade these. So what we end up doing is to try and rank order them, but not necessarily by cleverness, although that counts. Work, total work certainly counts a lot. How much time did you put in? Did the final result match your specification that you gave us 5 weeks before? But the fact that this is subjectively rank ordered is inescapable in a course that has open design. If you don't like it, don't take the course. Final project will be broken down about the same way. I think the breakdown is slightly different. I believe it's 20% on effort, 30% on result, 50% on lab write-up. There will be a bonus for getting done early. It goes as the square root of the number of days early. I love these nonlinear things. But there's a sweet spot around 7 days where the trade-off is pretty good. This is designed for a couple of reasons. One is it tries to keep the TAs and me from going nuts the last 3 days grading 50 or 60 projects. And secondly, it's kind of like real life, where you may get a bonus for getting done early. And lastly, you may help your grade by participating in help your grade by participating in class discussions and asking questions in class. And excessive non-attendance in lecture may lower your grade. Excessive non-attendance. Oh, 3 years ago, 2 years ago, there were a couple of people who never came to lecture. They lost some points. I don't often use this. Usually only if it's egregious. If you feel you've been unfairly graded, you have 1 week from the time the assignment is handed back to ask for a regrade. There are no tests. I think tests are useless in a design course. There's some laboratory policies, but each student in the course is expected to abide by Cornell University Code of Academic Integrity in the context of this course. You're certainly allowed to talk in lab. If somebody else in the lab says, hey, what's the name of that register? You don't have to say, I can't tell you, you're not in my group. You can, of course, tell them. So the breakdown is basically that as long as you're talking, if you're talking to somebody about code or about their hardware, that's fine. As soon as you pick up the mouse and move the mouse for them, or put a wire in their whiteboard, that is not allowed. So, allowed, homework and code must be shared within a group, and not allowed is sharing of any material between groups. Allowed, talking in lab about code with another group. Not allowed, emailing code to another group or using another group's keyboard to enter code. Allowed, showing another group your circuit. Seems reasonable. What did he mean by SPI? Where do those wires go? That's fair enough. Okay. What's not allowed is wiring for another group or lending them your circuit. I've seen that happen. Gee, this looks familiar. I have a pretty good visual memory for circuits and for artifacts in displays. So I can often detect copied code by the way the TFT boots. I'm not kidding. Not allowed copying anything, even one sentence, from any web or printed document unless it's quoted. It's really easy, once you get in the habit of this, to detect words from Wikipedia. There's a style that Wikipedia encourages. You get somebody, they're writing along, and suddenly there's this thing that's boilerplate sales speech. Wait a minute. So don't do that. And allowed is using code from previous final projects or web sources with attribution, but not allowed is without attribution. That's going to be of relatively little use this year because there's no code for PIC 32 from the course. So you're going to be writing the code basis for next year's class. Yeah. There's a section on lab reports next. You obviously are going to read that. But also, you might notice right here are some PDFs of good labs that you might want to read to see the level of detail we expect in a lab report. They won't be literal because, of course, these are all AVR, but this will give you a level of abstraction that you need to understand. Read this page completely. You are agreeing to it by taking the course. You better know what it says. I used to give a quiz on this page. I could still do that. Any questions about the logistics? Yeah.
Do you have to go to your scheduled lab section, or is your lab partner?
Your lab partner must be in the same lab section. You will be in your scheduled lab section, and your lab partner must be in the same lab section. If during final project you want to make a group that spans lab sections, then the demo will be due at the earlier lab period. Aha. I've seen this one before. Yes? Homework is required to be done in a group. One homework per group. You hand in 2 homeworks? Well, first homework, okay, because some of you may not have groups going into the first lab. You may get assigned a person in lab. We'll take multiple homeworks that time only. After that, it must be a group. What else? Okay, this year's projects. Capacitance meter. So you're going to plug in a capacitance, reads the value on the TFT display. We're moving from alphanumeric LCDs to full graphic, full color LCDs this year. 320 by 240 full color, 2.2 inch diagonal. They're just the cutest little things you ever saw. They're just beautiful. You will read the capacitance out on the meter along with whatever documentation you need to make sure that the code is running. You might want to have a blinking LED on the screen or on the board, whatever it is. DTMF dialer. You know what DTMF is? Dual tone, multi-frequency. Those are the tones you hear when you push the buttons on your cell phone. Boop, beep. You know those things? So it turns out in the bad old days when there were actual phone lines between phones, there needed to be a way for analog systems. This was all analog. There had to be a way for analog systems to signal each other. And the way this was done was to choose pairs of frequencies to represent digits and send the audio over the copper. And the audio was chosen in such a way that human voices can't generate the tones. And so the two tones that are generated, that's why it's called dual tone, the two tones that represent each digit are non-harmonically related, which most people cannot do. Can any of you hum and whistle 2 different frequencies? If you could, then you could do DTMF by whistling. There's been at least one person who could do this because he could dial by whistling and humming. You're going to build a DTMF dialer. It's going to, with some memory so that you can enter up to 12 digits and then it'll play them back at the DTMF standard signaling rate. This is a CCITT standard, I think. Then we're going to do an NTSC television video game. NTSC is an old analog standard. The reason for using it is that the write rate to the television is very high, so you can do good animation. Also, a television screen is the cheapest LCD display you can buy. They make millions of them, even though this isn't used for broadcast anymore, right? This is completely obsolete for broadcast. What do you think the major market for NTSC televisions is right now? This one completely floored me when I found out. Backup monitors for cars. Those things on your dashboard are NTSC televisions. They're cheap because they make millions of them to put in cars. Lab 4 will be a motor controller. Did I spell it right this time? Yeah. Controller and tachometer. So you'll build a tack that allows you to measure the speed of a fan. And I will ask you to write a PID closed-loop control system. Oh, more differential equations. A PID control system to regulate the speed of the fan within a few RPM. And to change with good transient response and the usual stuff you want to do with a control system. And then for the last 5 weeks, we'll turn you loose. Build whatever you want, consistent with a few rules. One, total cost has to come in less than $100. I will buy about $20 worth of parts for a group. If you need a transistor, a few LEDs, 100 LEDs, we'll buy that. If you want to buy a couple of Bluetooth transceivers, you buy them. Total cost is going to be less than $100. Absolutely nothing can be built that approximates a weapon system. No surprise there. In the broadest possible terms, no ping pong cannons, no knife throwing devices, no laser mosquito killers. You know, nothing like that, right? Also, nothing that involves alcohol or drugs with, you know, advanced vaping device, you know, no, nothing like that, with the possible exception of a breathalyzer. If you can describe to me how you will ethically test it in lab. What you do on your own time is not my business. But when you demo it, you better not be drinking a beer, right? So you have to tell me how you're ethically going to test this in lab. So those will require previous approval, right? I will have to see your plan based upon your 2 to 5 page proposal. If you propose a breathalyzer, there better be a test plan that makes sense. Otherwise, it'll just be, no, you can't do this. Any questions on final project? It's early, but it's not that early. 2 years ago, I had a group started on the first day. By the end of the first month of class, they had laid out and sent off for fab a circuit board. They got it back 30 days later. They built a beautiful watch with LiPo charger, micro SD card, 60 LEDs, 0402 surface mount. Oh, kill me. And a couple other things, all in a very professional looking package. If you want to do something like that, you've got to start now. You got no time. All of these exercises have a technical component and a theoretical component. The technical component of the capacitance meter is timing, and a major a major theme of the course is timing. How do you control events in real time? It's all real-time programming. How do you control events? How do you make a synthesizer, audio synthesizer that runs at a uniform rate? How do you detect events accurate to the nearest fraction of a microsecond? How do you handle time? In capacitance meter, you're going to have to detect when a waveform crosses a threshold within a few nanoseconds. So it's timing and input capture. Also setting up and learning how to use the TFT display, the LCD display. Learning how to use proto-threads, which is a lightweight threader. All of the labs are going to be written in a threaded style. I am going to require that, with the possible exception of the video lab where real-time performance is so important that you may not have time to do the context switch. But all of the labs except for that will absolutely be required to be in a threaded format, because it makes your life easier in the long run. So you're going to learn to use proto-threads. Second lab, DTMF dialer, will be using an SPI DAC. You know what SPI is, right? Serial Peripheral Interface. Look it up, folks. Serial Peripheral, I'll talk about it also, but Serial Peripheral Interface is a fairly fast serial, asynchronous, asynchronous, that is to say, it has a clock, interface going to a 12-bit DAC. You're going to have a keypad hooked up. You'll have to learn how to scan the keypad and how to do direct digital synthesis for making precision sine waves at precision frequencies. Video game, NTSC vector dynamics, direct memory access. You will have to use direct memory access. Part of the lab will be to have you use direct memory access to drive a DAC which is internal to the microcontroller. It's only 4 bits, so it's kind of cheesy. It's a 4-bit DAC, but you can run it really fast. So you can do sound effects. You can even do voice through it. 4-bit voice is just fine. So you can do things for your video game like, say, loser! You know, you can make any sound effects you want, but there have to be some, and it has to be direct memory access. It can't work through the CPU. Motor controller, we'll be using infrared sensors. RS-232 serial, so that's an old style serial protocol which is actually still used quite a lot. Opto-isolators, because you are nuts if you drive a motor directly from a CPU. You have to use opto-isolation, otherwise the noise will kill you. And true, isn't it? Yeah. And PID control, so proportional integral differential control. So that's where the calculus comes in there. All code examples are online, as I said. Bring your laptop if you want to follow along. Yeah. For the final project, you must stick with a PIC32. You can use another variant on the PIC32. We're using the PIC32 MX250 F128. If you wanted to use a different chip, let's say one that is in thin quad flat pack with more I/O, I would allow you to do that assuming that you buy it. And the downside of that, the upside of that is you have more I/O. You could have hardware Ethernet if you wanted it. The chip we have has hardware USB, but it does not have hardware Ethernet. You have to add that. Some of them have hardware Ethernet built in. The downside is there ain't no support for it. You do that, you are on your own. So, has to be PIC32 architecture. We're not falling back to 8 bits. You can't use an ARM. Yes? In addition to it. Ah! Yes, half of the work has to be done on the PIC-32. The other half could be done on anything you want from Android to Windows. So if you had a project that required a bunch of MATLAB processing on the back end, you could certainly do that, as long as it is still primarily, more than 50%, a microcontroller project. So if you wanted to make a data acquisition system, 1 megahertz data acquisition system for your Android phone, well, that sounds cool. I have no idea how to do it, but maybe if some of you might. What else? Any other questions? Read Lab 1. Start reading the support pages, the TFT page, the ProtoThreads page. There is a lot of reading to do before Monday. Monday is the last time you can answer questions. No, I answer questions. You ask questions. So come next time, Friday, with lots of questions, folks. Thanks.